Okay, welcome. Today we're going to look at some exponential growth models, and which can be applied to exponential decay models as well. So go ahead and take your notes out, and remember this is just an add-on to yesterday's notes in case you need some more help. And we'll begin. Remember to pause the video if you fall behind because you want your notes to be complete, and pause the video if you didn't quite understand something the first time and listen to it again. All right, today we're going to look at example 4. This is out of section 7.1 in your book and applies to 7-2 as well. And here we go. Computers. In 1996, there were 2,573 computer viruses and other computer security incidents. During the next 7 years, the number of incidents increased by about 92% each year. We want to write an exponential growth model giving the number n, so n will be our number, of incidents t years after 1996. Then we want to go to estimate about how many incidents were there in 2003 based off our model. Then we'll graph. Alright, so the key to the problem is, first of all, using the right formula. And because this is a growth, every year they're increasing, we have to use the y is equal to, and remember, write the exponential function. There it is. This is a similar function. This is y is equal to a. Remember, a is our initial amount. But our b, our growth factor, is the 1 plus r. And our x is our variable, and that's going to be, in this case, t, time in years. Okay, remember the 1 plus comes from, if I just use r, I'm just finding the percent it grew by. I'm not finding the new amount, so we have to add the 1 back into it. So this is 1 plus r. So go identify what we need. We need an a, which is our initial amount. Let's see, we started in 1960 or 1996, so that's when t was 0, by the way. And there were 2,573. So there's your a, your initial amount. We need a rate. Let's see, the rate is 92, so there's your r. And remember that if r is 92%, then we have to switch it to a decimal, which would be 0.92. So make sure we hit that, and that's all we need. Now this is just a simple substitution, so we're going to go ahead and do that now. So I'm going to switch the page. Okay, so we have identified a, r, and with a simple substitution, remember we always write down the formula. There's your a, there's your r. Now we need to combine those terms, and there's your function. From this function, we can estimate about how many computer viruses for any year since 1996. And I believe they want us to do 7 years, so that's when t is 7. So we're simply going to plug in t for 7. Okay, so that's where this 7 came from. We just plugged it in. Okay, this is a calculator problem. So you're going to type in 1.92 to the 7th power. Remember your order of operations. And then multiply it by 2,573. Again, calculator problem. That's approximately 247,485. Okay, the last step to our problem, after simple identification, substitution, and simplify with a calculator, is to graph. And graphing gets kind of crazy. I use Desmos to graph. Oh, sorry about that. Let's get that back where it should be. I use Desmos calculator on the graph, and the problem you're going to find with the graphing are the numbers are pretty big. So if we look at the problem here, we're going to see that our values grow rather rapidly, but our years are kind of small. Now, if we don't skew our units, meaning, from here, 2 units here is 50,000, so they're going every 25,000. These are going by ones. You put that on Desmos, and it's going to look like just a straight up and down vertical line. So what we have to do is kind of skew the units. You got to think about how to graph these guys a little bit. And that's all dependent on your numbers. All right, graphing. Remember, we plugged in a few numbers, and we always went with 0, our initial time. So we know at 0 we're going to be 2,573. Now in our graph, that's really hard to see. It's about in here. So we're going to have to just basically do an estimation. At 1, we jump up to 4,940. So at 1, we're about in here somewhere. And for this particular graph, we don't need negative numbers because we're not going that direction. We start at 1996, so we don't need to put in the negative numbers. So we'll find a few more positive numbers. And like if you plugged in 6, you get a nice number like 125,000. So when you do your graphs, you're just going to have to kind of plug in numbers and estimate. And you're going to have to use the units that fit your graph the best. And remember, it's just a rough graph. Okay, hopefully it helps with these types of problems. And again, we can use these with the decay problems, and the only difference is the formula, the 1 minus r instead of the 1 plus r. Okay, hopefully this helped do your word problems. If you have any more questions, remember, write some notes down and we'll talk about them in class.